Welcome to ClickMyProject.com. Now we are going to discuss about the project on discriminatives and symmetric in ear biometrics. Now we are going to discuss about the abstract of the process. In this process, the ear biometrics has been used for gender classification and authentication system, mainly used for the authenticating the people whether the input person is the authenticated or not. Identifying a person and classifying the male or female is an interesting problem and is required in many practical applications. The ear hole has been considered as an primary references point to detect the persons. So each and every person's unique persons will be detected based on the that features only. Hence the features are taken and relative the distance, that is the Euclidean distance, have been measured between the ear identification points, ear features and the ear hole. This is the main key point of this project to detect whether the person is authenticated or not. The ear features considers are outer lobe edge and outer and thinner curves of the helix and edge. We have used a dataset both of male and female for the classification. Hence this project consists of three major steps like feature extraction, classification and performance estimation. By these three only we can justify whether the input person is authenticated or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists of the modules such as the input ear image, pre-processing, feature extraction, classification, post-processing, then finally performance estimation. By these modules only we can doing the process. First of all, the input ear image is taken from the dataset. The dataset consists of the lot of ear image which is having the both the male as well as the female images. After getting any one image from the dataset, the collected image will be doing the pre-processing. So in this pre-processing there are two stages of pre-processing is there. One is the image resize and then the another one is the grayscale conversion. In this image resize, the dimension of the image will be resized into 256 cross 256, which means the number of row will be the 256, number of column will be the 256. After doing the image resize, we are just doing the grayscale conversion. So in this grayscale conversion, the RGB image is converted into one grayscale like this. You can see the difference between this input and then this grayscale converted image. So the grayscale conversion is just for converting the RGB band into one grayscale. After doing this one, we are just estimating the color features in the feature extraction module by using the algorithm HOG. By using the HOG patterns will be formed like this. From this we are going to extract the pattern features from this HOG as well as the colored features from the HOG. After extracting these features, we are going to do the classification. In this classification, deep learning is used to classify whether the input ear is authenticated or not. So first primary objective of the project is to detect whether the person is authenticated or not. Then the secondary thing is the gender classification, whether the input is male or female. After doing this, the post processing, the results will be displayed according to the authentication's result. Then finally the performance estimation. In this performance estimation, we are going to estimate the performance like accuracy, sensitivity and specificity. In case of accuracy above 90 to 94.5% in this sense, the process will be the achieved good. Now we are going to discuss about the running procedure of the process. At first open the Anaconda, then IDE Spider 3.7. After opening the IDE, we are going to open the main file.py. After opening the main file.py, the run button will be enabled. After clicking the run button, the dataset will be open. In that dataset you can see the several images. You can select any one image from the dataset. After the selection of the image from the dataset, the corresponding process will be done one by one. Now we will discuss the results one by one. First of all, the input image. The input image is taken from the dataset by the user. After getting the input image, those image is displayed in this console window. This is the original image. After that, this is the resized image. So the resized image, the image will be resized into 256 cross 256. Like the number of row will be the 256, number of column will be the 256. After doing the image resize, we are going to convert the image into one grayscale image. You can see the difference between the RGB and then the grayscale image. Hence the pixel intensity will be only the 0 to 255. After converting the grayscale image, the segmentation will be carried out. In the segmentation portions, the outer regions of the ear shape will be segmented. So the segmentation is done by using the morphological and then the thresholding algorithm to segment the ear portions. After doing the segmentation, the feature extraction is carried out by means of the HOG algorithm. The patterns of the HOG will be formed like this. Hence the colored features is extracted by means of the HOG. Then the feature is called the test feature. After generating the features, we are going to extract the another features, that is the GLCM features. So the gray level co-occurrence matrix is extracted from this. This picture represents the features of the GLCM. After that, we are going to combine the features of GLCM and HOG together to generate the test features. After doing the feature extraction, the classification is done by using the convolutional neural network. So the convolutional neural network is a kind of deep learning method to classify whether the person is authenticated or not. So this is the graph represents the loss functions. Hence the loss functions will be in the minimum rate only. After doing estimating the loss function, everything, the authentication results will be displayed like this. Hence the person is authenticated or not. So the input image is authenticated, the results will be displayed as authenticated. In case if the input image is not authenticated, in this sense the classification results will be shown as not authenticated. Finally, the accuracy, precision, recall, error rate will be estimated. Then those values are plotted here, as well as the existing and proposed of machine learning and deep learning is differences shown here. Thanks for watching this video.